Graphical interfaces were designed for human hands and pacing, but replace the human with an autonomous node, and execution speed outpaces the interface itself. This is robotic process automation. It operates directly at the presentation layer, bridging legacy systems and modern applications by executing commands exactly where a human would. For years, IT departments viewed this technology with skepticism, equating it to fragile screen recording macros that relied on exact X and Y mouse coordinates to click buttons. Enterprise-grade automation requires precise element targeting, structured data management, and centralized exception handling built into its core architecture. UiPath divides this architecture into three distinct components: Studio for development, the robot for execution, and Orchestrator for management. Building a resilient digital workforce requires abandoning the macro mindset entirely and adopting strict software engineering principles from the ground up. The process begins in UiPath Studio. Here, developers construct linear logic using visual sequence blocks. Before a bot ever attempts to interact with an application's user interface, it must establish a secure way to hold and manipulate data in active memory. This 3D grid represents a data table. It acts as the primary memory structure, organizing raw incoming information into distinct rows and columns, much like a database table. Once the information is secured in this grid, the bot uses logic blocks to rapidly filter, sort, and iterate through the specific data points it needs to execute its task. Often, bots bypass graphical interfaces altogether. UiPath can extract structured data through direct backend connections. Developers configure HTTP requests to communicate with JSON or XML APIs, or write direct SQL queries to pull records straight from a database. Extracting data through these backend channels is always prioritized over scraping a user interface because it eliminates the risk of rendering delays and ensures absolute accuracy. Securing data integrity means isolating the heavy data manipulation logic from the physical UI interactions. Graphical user interfaces are inherently unstable targets. Web pages load slowly, screen resolutions vary, and responsive designs cause buttons to physically move. Look at this interface peeling back. UiPath ignores the visual pixels you see on screen and instead scans the application's underlying document object model, or DOM. To interact with the application, the bot uses selectors. These are specific XML fragments that lock onto unique underlying element attributes, like an object's ID or its class name. Here, the selector zeroes in on the exact code string identifying the Save button. It knows what to click by reading the code, not by looking at the screen. However, if an application undergoes a minor update and the exact layout changes, a highly specific, rigid selector will fail to find its target. This visual shows a fuzzy selector in action. By introducing wildcards into the XML fragment, the bot employs a more forgiving search algorithm. This fuzzy logic allows the bot to maintain its lock on the target element despite minor structural shifts or typographical errors in the application's code. When structural targeting is impossible, such as working inside Citrix virtual desktops or reading scanned PDFs, UiPath deploys a fallback protocol. The bot activates optical character recognition and image automation to scrape unstructured visual data directly from the pixels on the screen. UI automation is actually an exercise in structural data querying. The bot searches the code, rendering surface-level visual changes irrelevant. Production environments are chaotic. Network connections drop, servers time out, and incoming data formats are frequently malformed. This flowchart illustrates the try-catch block, which serves as the primary architectural defense against execution failure. The bot attempts its standard tasks within the try execution path. If it encounters a failure, the execution immediately diverts to the catch path to deploy a designated recovery protocol. Unforeseen infrastructure crashes, like an application timing out or a null reference, are classified as system exceptions. The recovery protocol for a system exception is usually to loop the execution back through a retry scope, assuming the network or application issue is temporary. Now the flowchart updates. It shows a distinct secondary routing specifically for business exceptions. A business exception occurs when data violates explicit rules, like an invoice missing a required purchase order number. The bot logs the error, notifies a human operator, and immediately skips to the next transaction. It does not retry. Regardless of success or failure, the process routes into a finally block to guarantee secure closure of the applications and release the system memory. A bot's enterprise readiness is measured entirely by the sophistication and reliability of these failure protocols. A flawlessly engineered workflow running on a single local desktop is still an operational liability. It cannot scale to meet enterprise demand. This diagram maps the scaling process. The local Studio package is pushed up to UiPath Orchestrator, a centralized cloud hub. Orchestrator then distributes that workflow to a large fleet of unattended robots. Orchestrator organizes these execution nodes into strict logical environments, clearly separating development, testing, and production operations. Massive workloads are broken down into individual, trackable data points using Orchestrator's queue management system. Orchestrator dynamically distributes these transactional items to the available unattended robots, automatically adjusting the workload based on strict service-level agreement priorities. Operating at this scale requires enterprise-grade security. Orchestrator enforces role-based access control and applies SSL encryption to all data in transit between the robots on the server. With Orchestrator, management moves from individual desktop scripts to a cohesive autonomous fleet, governed through a single control point. This macro architecture links the complete UiPath triad. Studio serves as the design environment, structuring precise data logic and exception handling. Orchestrator operates as the command center, governing queues, enforcing security, and scaling deployment. Robots process the try-catch logic through seamless API and XML-based interactions. Before this architecture goes live, organizations subject the workflows to rigorous software quality assurance, executing unit testing and load testing to ensure stability under stress. Precise DOM selectors, strict error routing, and centralized orchestration turn RPA into a resilient, mission-critical layer.